Namah Shivaya, this is Sriram Raghunath from CSCB. Today I want to explain a problem using dynamic programming. Today I want to explain this problem based on dynamic programming. Here we want to find number of distinct subsequences. There may be repeats of subsequence in a string, so we want to find a distinct without the duplicates. Here we see dynamic programming, how we use dynamic programming. First, see our logic. For example, C string ABC. Initially, we take the DP of 0 is 1 as the empty string also be as a substring. For the first one, there was A. It was 2 times the previous one. If we took B, it was AB, the second DP2. It is the 2 times of the previous one. For you can see the empty string A, B and AB. Similarly, if we add another distinct item, element distinct character, then will be d of 3 will be 4 into 2 times the previous one, dp of I minus 1, which is an empty string a b c a b a b c. In this here we can say we are using the previous one, and similarly if there was duplicates, we can remove them by removing the previous repetition from the twice of this from the next. So here we are using the subproblems and the optimal substructure properties in the code. The optimal substructure, as we are reusing the previous codes to get the current code, and we are using the making the big string into the substring, and we are initially we are 0. We are taking the first, we combine is 2 3, and we are comparing the individual, and the logic was simply compare the previous. If it was distinct, it will be twice. If it not distinct, we'll remove the we'll check the uh, previous location where the A was there, and we'll remove the number of repetitions from the and we will update them in a unordered set. We'll update the A, B, and the unordered set, so that there won't be any repetition in for every time. So if there was a new A, the memory will be located to the new one. For example, here there is another A, then it will locate to this A. If the next one, the A is located to fourth one, DP of fourth, rather than DP of one. So after the at the last of the another set, using another set, so there won't be any duplicates. After the iteration, we'll update the location. We'll see the code in form of code in the next slide, so that we can understand it more effectively and easily. Then I want to explain the code using the logic which we saw previously. Here, until this is now everything. Here, in distinct subsequence, I call a method which I give the argument string. For here, I used another map to save the latest occurrence of the character and its indices. In, for example, we take a string A, B, C, D, A. Although after the according to the previous logic, after after a new A, we no need of previous A. Yes, the new A contains new all new substrings which are distinct. So we no need of the previous one. So we use a map so that there won't be any duplicates, and we will consider the latest one. So we will take the we will take the length of the string, and we will create an array. Initially, we will take the dp0 as 1 as, because if there is no character, there is a substring which is the empty string. Later we comes to the for loop. We give a for loop, we transfer from in the string. If we take the first element, if the first element is not found in the map, means there won't be any duplicate. It was not a duplicate. So it will the twice, as we discussed about, it was twice the times of the uh, previous number of strings, substrings. Here in else case, we'll consider if there was not a, it was a repetition. It was found in the map. Thus, then we'll take the twice and we'll remove the previous occurrence of the same character in that string. As it was as we consider the map, in the map, the latest, as we use the ordered unordered map, there was the latest occurrence of the character. We store the latest occurrence of the character so that the latest, without any duplicates, the everything will be removed. And later, and at the end, we'll come out of the files. We can see the map. Will in the map we'll store the latest occurrence of the character, and we'll return the last and last length, the last character of the DP of this storage. If here we declare a main method, and in main method we give some arguments, and we'll print out we'll print the output. We'll see the output in the next slide. By in the above code, we run the inputs. We'll get this outputs as there was no occurrence, no repetition of the character. So it will be 16 outputs. There was a repetition here, so that it was removed in the previous one. According to the previous one, it was removed A, B, C, D, A, and excess one was removed from the string. Uh, so the output will be 31. Thank you for giving this opportunity. Thank you for this. Thank you, sir.